over 16 plus x to the fourth. I always go through this strategy, mandatory, because if I skip anything, I will get in trouble. It will be difficult, or I make it difficult on myself. First of all, it's a binomial, so I will end up somewhere here, maybe, if it's factorable. If it's not, it's a different story. But I start from the top. It's in descending order. No, it's not. So then I have x to the fourth minus 1 over 16. Then is there a greatest common factor? The answer is no. Is there a negative leading coefficient? The answer is no. So then I'm down here where I see the difference of squares and the difference of cubes. And I have to establish which one. I have to tell you that in certain situations, not too many, both work. Well, in this case, x to the fourth has nothing to do with a difference of cubes. That's not, yes, please.
Isn't it negative x to the fourth? Because you moved them?
So I can say to the bank, 5 minus 10 is the same with 10 minus 5. So I can tell them I owe you guys $10, but actually, because I owe you $10, you owe me 5. See my point?
Yeah.
So when I switch around, when I take this number, I have to take it and copy it with a sign in front. I cannot change it all of a sudden into positive. If it's negative, it has to die negative. So this was positive x to the fourth, it has to die positive. And this one is negative 1 over 16, it has to die negative 1 over 16. So when we switch terms around, we take quantities, terms, with the sign in front. Better? I wish I could tell that to the bank. All of a sudden, you owe me what I actually owe you. Okay. So that's incorrect. So 5 minus 10 is negative 10 plus 5. Very good question, actually. Don't you ever get shy of or refrain yourself from asking any question. So you are helping me when you ask questions. So not just yourself. Okay. So it is in descending order. Greatest common factor, no. Negative leading coefficient, no. Special product. So I'm down to the difference of squares. And when I think of the difference of squares, I can already picture a product of two binomials. And now the question is, those binomials are what? I mean, how do I get that? So as we discussed last time, I need an a plus b and a minus b, or I need an a minus b times a plus b. It doesn't matter. The order is not important. So what do I square to get x to the fourth? Absolutely, it is x squared. And what do I square to get 1 over 16? Perfect. So this is x squared minus 1/4 and x squared plus 1/4. If you watch the videos carefully, you realize that x squared plus 1/4 is or is not factorable. Careful, sum of squares is not factorable. This stays as is. But the difference of squares, I can apply the same formula one more time, or the same special product. So how do I write this as a difference of squares? Yes, and x plus 1/2. So this is the complete factored form of x to the fourth power minus 1 over 16. Questions? Please.
Maybe I didn't notice where the sum of squares was connected to what we're doing here.
This is the sum of squares
Oh,
that I
so
have to
that's what we're
copy.
asking, so.
Yeah, the sum of squares has to get copied. It's not factorable. So when I'm asked to factor, I'm asked to completely factor. And I can completely factor x squared minus 4 into x plus 1/2 and x minus 1/2, but this, whatever I do, is not factorable. It is, but not using integers. So this was the sum of squares. The sum of squares is not factorable. The difference of squares is, the difference of cubes is, the sum of cubes is. Good. Okay, moving on. Other questions? Next. Anything else? So the lecture from last time had a lot of stuff in here. The difference of cubes, the sum of cubes, factoring trinomials with the leading coefficient 1, factoring trinomials with when a special product is applicable. Are we okay? Yes, please.
Can we do factoring a trinomial when the leading isn't 1?
Correct. Yes, of course. Allow me to do one with when the leading coefficient is 1 because I'd like to compare them, and then we move on. After that, I'll answer your question. Is that okay? Can we wait for 1 minute so I can, because I'd like to connect the topics. So am I to assume that you have no questions and everything is understood till we get to factoring trinomials with the leading coefficient that is not 1? Yes, please.
I have questions, but not like exactly like conceptual questions.
Yes, please do. Please.
So my first one, because I did more homework than I should have.
Right,
But
that's
I
fine.
came across some confusion. I don't know when a negative sign is subtraction or if when it's an actual negative sign. I was getting confused.
Very good question. So let's look at the following situation. Thank you, sorry. Sorry, thank you. Okay, first of all, here, the negative symbol in front of 2 indicates that 2 is a negative number. And then the power indicates that I have to square negative 2. And when I do that, I get the answer to be positive 4. Excellent. This is it. In this situation, I'm specifically told you have to square 2. When you're done, make sure you multiply by negative 1. So here I square 2, I get 4, I have to multiply that by negative 1, so I get the final answer as being negative 4. That's one thing. Now, for example, if I have this situation, assuming you're also considering that option with a negative leading coefficient, I'm not sure. I'm trying to answer all possibilities. But you may not have this question, but I'd like to discuss it for a moment. So if I'm asked to factor this, first I will identify it based on my sequence of steps. I'll identify it as a binomial, but I still go through all the steps, descending order, greatest common factor, negative leading coefficient. So I see that there is a negative leading coefficient, and I will have to pull it out. If I don't, then the factoring will be more difficult, and when I get to solving equations, I may encounter problems. So I will always factor out a negative leading coefficient. No matter what book you're reading, you should always factor out a negative leading coefficient. Because now it's easier to factor, and you always keep the polynomials in descending order. So then I have a negative outside. I will use the difference of squares into x plus 2 and x minus 2. Is everyone okay with this? Yes, everyone? Are you able to follow this? Okay. Did I answer your question, or is there another option that I didn't think of?
Yeah, it's a little bit
Yes, please.
complicated. It's right.
Excellent.
There.
Okay. So very good. So we want to simplify this. Excellent. So it says find the values of x such that, okay, so we are solving an equation here. So first of all, we are told to solve this equation. Very good. And now let's see the left-hand side, which is y. So we are told that y equals 3, a bracket, x minus 5 minus x in parentheses, minus 5 times x plus 1. Just make sure I copied it correctly. So we are given an expression for y, which has brackets and parentheses. We have to use the order of operations, but let's take it slowly, step by step, and see what this really means. When we are done simplifying y, we're going to create that equation that you see at the top. But first I have to simplify y before I create the equation. Is that okay, everyone? Perfect. So I look at all this, and it looks like something complicated. It's not, but we have to decompose it, or if you want, work on it step by step. So the first priority is to eliminate parentheses. That's the first priority. The second priority is to eliminate brackets. And the third priority, if we have any, which is not the situation here, braces. So brackets, braces, parentheses, this one. So the first priority, parentheses, brackets, second priority, and braces the last one. You're not going to have all three. It would be very unusual. But it's possible. Not in this class, though. Okay. So since I have to eliminate parentheses first, I need to worry about this. And I need to worry about this. So then y equals, I copy the 3. I copy the bracket. I copy the x. So far I didn't do anything. I'm just copying. 3 bracket x. And now I have here two options. I either say -1 times 5 and -1 times -x, which means I distribute -1. Or I say the opposite of 5, the opposite of -x. It's up to you. So, but I still have to write -5 plus x. Is this acceptable? So far, so good? Okay, in the same way, I will eliminate the second set of parentheses by distributing -5 this time and getting -5x and -5. Would you agree so far? So I have to distribute -5 to x and -5 to +1, and this is what I get. Okay, at this point, I have to combine like terms inside the bracket, because that's my next priority. I have to remove the brackets. So then I'll say y equals, I copy the 3, but now inside brackets, I have an apple plus an apple, which is 2 apples. Here, there is nothing I can do. And I'm at the stage in which I'm ready to simplify by removing the bracket, or the brackets. By distributing 3 to 2x and 3 to -5, I accomplished that step, which is, so 6x minus 15 minus 5x minus 5. All I have to do now is combine like terms. And I have a 6x minus 5x, which will give us an x. And I have a -15 with a -5, which will give us a -20. So this will be x minus 20. Is this clear so far? So then y is completely, if you want, fully simplified. And now I can go back and create that equation. Only now, when it's complete, I like to say it's completely cleaned up. Y is as simple as I can ever dream of bringing it or turning it to. So now I have x minus 20 equals 0, and I move, and this is a very good example because we will review linear equations today, and this is basically it. So all I have to write is that x equals 20. Very good question. Thank you for bringing that up. Any questions, anyone? Are we okay with this? Okay, since now we're ready to work on a problem like, I'm going to pick from your book. I am going to pick a problem and see that you have mastered factoring prior to your colleague's question. I will know your names very soon. So I'm looking to copy a problem. I just found it, and here it is. So let's say I would like to solve the equation x squared minus 8x plus, not equation, we're not solving. We're just asked to factor this. So then we can move on to the last type of trinomials, which is basically the most difficult one by far. So we're factoring x squared minus 8x plus 15. If anyone would like to explain the steps or tell us how to factor this, that would be great. Raise your hand if you need help. I'll come and help you. If you did not watch the videos, I'm hoping that you will between now and Wednesday, so you don't fall behind. Anyone needs help? On this problem, x squared minus 8x plus 15. Hoping you're going to watch the videos so we can discuss everything in class. I'm hoping you're going to watch the videos since I begged you to several times with lecture notes. It explains everything step by step so we can make progress. I'm not really happy to see what I see. We only have 15 weeks for this class. Okay, so let me refresh our memory on how to approach this problem. We're looking for two numbers. Of course, I have to go through the steps. What is it? It's a trinomial. It's in descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, I hope. A special product requires these two to be perfect squares. They are not. So it's not this, it's not this. And it's the third one in line because the leading coefficient is 1. Okay, so we're looking for two numbers whose product is indeed 15 and whose sum is -8. Awesome. Great job. Good. So here's how I start. I always start with the product because the product gives me a lot of information about the numbers I'm looking for. The product is positive, which means there are two options here. Either both positive or both negative. Now I look at the sum and decide exactly which of these two, not both, of course. If they're positive, of course, thank you. If they're positive, I can not add two positive numbers and get a negative number. So this is not an option. So both numbers have to be negative. So now let's find two numbers whose product is 15 and whose sum is -8. Both of them being negative. -3 and -5. So now from here, I don't have room, so I can immediately write the factored form. You understand that if each problem, when we need to factor, if it takes us 10 minutes to factor, we're not going to get anywhere. Okay, so when we factor this, we get exactly what you just told me, x minus 3 and x minus 4. It will only take you 5 seconds to verify this. How would you verify? Very good. I'm sorry. Of course, 5. Sorry, it's 5. So thank you very much. My apologies. So how long does it take to figure this one out? I mean, check x squared minus 5x minus 3x, and negative 3 times negative 5 is positive 15. Okay, and now I would like to go back to the actual question. Any questions on this?
If we would have put negative 5 and 5.
It doesn't matter because 5 times 3 is 3 times 5. So it doesn't matter. You can write it as x minus 5 times x minus 3 is the same thing. It doesn't matter. The order in a product doesn't matter. In a division, you cannot do that. In a sum or a difference, you can. And in a product, but not in a division. Yes, it doesn't matter. Good. So are you comfortable with this? If you're not comfortable with this, you will be comfortable between now and Wednesday, right? Please, this is extremely important to move on. Okay, so now we want to choose a problem like, for example, 6x squared plus 11x minus 10. Now this is a different story. This is the most difficult one. If you had worked on the first one, this would be much easier to understand. If you hadn't, then you're going back to square one. So please. Okay, so I am looking at this polynomial, and I know it's a trinomial, so I know I'm going to end up here. But I go from the beginning. It's in descending order, yes. Greatest common factor, no. 6, 11, and 10 don't have a common factor. Negative leading coefficient, no. Special product, I always hope for a special product. From these two, I will look at the one with the plus. But this is not a perfect square, and this is negative, so that's not allowed. So they cannot be a special product. Is 1 the leading coefficient? The answer is no. So this is my last resource. If this doesn't work, there's nothing I can do. I would have to write that the polynomial is not factorable using integers. Okay, so what did we do on the previous example? On the previous example, we said the product is excellent and the sum is? Right. Well, I didn't tell you what I did, but I'm telling you now. Well, the product is basically 1 times 15. But 1 times 15 is still 15. That's the only difference. So now this time the product is 6 times negative 10, which makes it negative 60. So at any point in time, the leading coefficient has to be taken into account. When the leading coefficient is 1, and there's nothing just to say about it. But when the leading coefficient is 1, I have to multiply it by the last coefficient. Remember, everything has to be in descending order. We call this the free term. Bless you. Okay, so the sum never changes. So this is 11. So now, again, the same thing. So far, this step is the same. We want the product. We look at the product first. It's a negative number. So then it's guaranteed if the product is negative, what type of numbers am I looking for? A positive and a negative this time. Very good. Awesome. Which of these two will have to be bigger, stronger in absolute value, we say? The positive one or the negative one? Right, because the positive has to overtake the negative to have an answer that is positive. So this must be bigger than this. Keep that in mind. Now you can say this 60 is kind of big, and I agree. Well, but 60 is basically 6 times 10. Acceptable? In prime numbers, 2 times 3. In prime numbers, 2 times. Excellent. So then 60 or 2 times 2 times 3 times 5 is the same thing. So I want two numbers from here using everything. One positive and one negative, such that when I multiply them, I get negative 60. And when I add them, I get positive 11.
4 and 15.
4 and 15. So this is one number, and this is another number. Indeed, 4 and 15. Which one is positive? Exactly. Now, you can no longer go back to the problem and say, oh, this is easy. It's x plus 15 and x minus 4. No, this doesn't work because the leading coefficient is not 1. It would have worked with the leading coefficient 1, but not now. So you cannot do that. Well, what can I do? Well, here's what I recommend. The reason I use this method is because we need it for this anyway. So we're going to factor by grouping. So what I'm going to do, so I'm going to continue here. I will write 6x squared. I will write positive 15x. I will write minus 4x, and I will copy the negative 10. You can say you're changing your problem. No, this is still 11x right here. It's still the same thing, 11x. But now, I will be factoring by grouping. What will you factor out from the very first terms? Very good. Excellent. What is left in parentheses? Excellent. Yes. I refuse to look before I copy it again. Again, you do not have to use my method. If it helps you, if you understand it, if you agree with it, use it. If you have a better method, use your method. I refuse to even look at the other two, in that direction before I write 2x plus 5 again. So now I know that I have to find a sign and a factor in front. But that's not a problem. Because I see negative 2 times 2x is negative 4x, and negative 2 times 5 is negative 10. If I don't write it first, before I figure out that negative 2, I may get confused. I may write 2x minus 5. Who knows? But if I know that that factor has to be there, part of the second term, I will never make a mistake if I write it first. I'm not going to force it. It has to be there. Once I found these two numbers, whose product is this and whose sum is this has to be there. Now this is the first term. This is the second term. These two terms have a common factor. Can anyone dictate the common factor?
3.
Of course. And in parentheses, from the first term, 3x. From the second term, minus 2. And that's it. So you can say, show me. Okay, these two, 6x squared, minus 4x plus 15x, 11x, and 5 times negative 2, negative 10.
Okay, if the middle term is flip-flop.
Yes, you will get the same thing. There is only one correct factorization. If I found this one or the opposite, you cannot find a different one. If this one works, you cannot find a different one that works. This is it. Very good question. Anything else from here? Anything else on this part of factoring? Why did my stuff disappear here? I'm not sure. Next question, please. Next question, or we move on?
Do you want us to refrain from asking questions from 1.2, 1.5.
Anything you want. Anything. I just wanted to go back into the course. Just to go back and show the lecture notes for the second one. And see if we have any questions on those.
So we can try that with the negative leading instead of positive leading.
Yes, any problem that you worked on that you would like me to go back to? Sure, of course. So, so this was the lecture from last August the 28th. So be very careful when you use the special product, right? We can work on any problem you want. So here I say, okay, it's in descending order, trinomial, no negative leading coefficient, no greatest common factor. And I say, okay, is a special product applicable here? Of course it is, because x squared is a perfect square and then 25 is a perfect square, so I'm assuming x plus 5, everything squared. But how many terms does x plus 5 squared have? Never, please. One more time. We talked about it last Wednesday. A binomial squared has how many terms? 3. Please always say 3. Please make me happy and say 3. So when you square this, you would have to square the first term and you get squared, plus 2 times the first times the second, and you get 10x, plus the second term squared. However, let me show you what example I gave next. Is this x plus 5 squared? The answer is no, because x plus 5 squared has x squared at the beginning, has 25 at the end, but it has 10x in the middle. 2 times the first times the second, not 7x. So the point I'm making is, if a trinomial uses a special product, it's not sufficient to simply look at the first term and the last term. You also have to make sure that the middle term fits. Is that clear, what I'm saying? Right, okay. So I'm hoping you're gonna watch this, so I'm just going through it. And these were the examples that I picked. So this is from the handout, so we worked on this, the same thing what we just did a minute ago. This was a minute ago what we just did, factoring by grouping. So if you know ahead of time what we're going to discuss, you're going to be much better off in class, because you're going to see this the third time, and that will really help you reinforcing the topics. And of course, I'll do any problem you want, anything you want me to work on. So these were the polynomials, and then rational equations and linear. We already looked at one linear equation. We can choose another, of course. And then I would like to work on rational equations. So assuming that you watched this like several times if you needed to and worked on these problems. However, I'll do any problem right now. So please choose what you would like to continue with. We have to move on. So I'll do any linear equation. I will do any rational equation. We're not going to be able to start quadratic equations yet today. I don't think so. But at least I want to review linear equations and rational equations, and then you can finish this one up, and the next one I will indicate which one. So from Wednesday on, I would like you to start working on your homework. Now you have enough information to work on your homework. So as an example, what I would like you to start working on, but after you watch the videos and after you ask questions, and you will go back and review and redo other problems. That's not a problem. You're not getting a grade right now for this homework. So don't get confused or upset that you get 10% maybe on some homework. You go back and redo it. Okay. So these linear equations and rationals and the factoring extra practice that we just looked at should be done this weekend. Hopefully, maybe quadratic equations as well. We'll see. I don't know that. We have to discuss that on Wednesday. But 1, 2, 3, potentially 4 should be done this weekend. And we still have a lot till test 1. Till here. Test 1 is after 2.5. Look at the syllabus on the last page. Okay, the syllabus, the last page, has the exact same order, and it tells you exactly what you need to do. Okay, so linear equations, please. Let's choose linear equations, rational equations. You tell me what you want to continue with, because that's what we need to do. Yes, please.
Can we do linear equations with fractions?
Absolutely. Just dictate one or tell me what it is, and I'm going to copy it.
Yeah, the first example they give is x plus 2 over 4 minus x minus 1 over 3. I think, I don't know if that's the original equation or if that's me working on it.
Can I see it?
I think that's me doing through it. No, so it is this one.
So x plus 2 over 4 minus x minus 1 over 3 equals 2. It was x plus 1, x minus 1 over 3
Yes.
equals 2. Okay, perfect. I see fractions in here. Is this linear or rational? Of course. Why is it linear and not rational? Because it doesn't have x in the denominator. Anything that has x in the denominator is a different story. This one has just some numerical fractions. This is not rational. This is linear. Perfect. What I recommend here is eliminate fractions. If I want to eliminate fractions, I have to find the least common denominator. I see 3 denominators. I see denominator 4, denominator 3, and denominator 1. And I want to eliminate all 3 denominators at once. What will I multiply both sides by? Very good. Since they are fractions, I recommend do this. 12 divided by 1 times 12 divided by 1 times 12 divided by 1. Why? Because I don't want to multiply. I want to simplify first. 4 divided by 4 is 1. 12 divided by 4 is?
3.
Is that okay? 4 divided by 4 is 1. 12 divided by 4 is 3. So then we get 3 parentheses x plus 2. Do we all agree with the first step?
Yes.
Perfect. So now I simplify by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So then I have to write negative 4 and x minus 1 in front. Negative 4 in front of x minus 1. And then here I have just 2 times 12, which is 24. So perfect. We just looked at an example a few minutes ago. I have to distribute, combine like terms. So I distribute first, and I get 3x plus 6 and minus 4x plus 4 equals 24. Do we agree so far? Any questions? Any questions? Any questions? Okay. Do not move terms around before you fully simplify each side. Well, in this case, I only have the left-hand side, which is negative 1, x or negative x, and plus 10. I always start with the variable. I always put everything in descending order. You can write minus 10 and minus 10 to both sides. Instead, I prefer saying that I move a term from one side to the other. Every time I move a term from one side to the other, it just changes its sign. There's nothing else. So I have negative x, 24 minus 10, which is 14. So negative x equals 14. Multiply or divide both sides by negative 1. X equals negative 14. And that is the final answer for this equation. Any questions? Any questions? Yes, please.
Not about this one.
Yes.
Different one.
Yes,
I don't
I'm
know,
ready.
I don't know if this is linear or rational, but it's 1 over x.
Ah, it's a different story. We
Plus,
wanted to start with this anyway, so please give it to me. That's awesome.
okay, plus 1 over x plus 4 equals 1 over 4.
Excellent example. This is a totally different story. This was my next step anyway. So why not choose this one? Perfect. Okay, so this is no longer a linear equation because it has x in the denominator. When you see x in the denominator of this kind of a problem, you know that this is rational. It's a rational equation. It's a totally different story. It's not a simple problem. It's, I would say, quite sophisticated. Very doable, but quite sophisticated. Okay, first of all, my first step would be to factor the denominators. But the denominators are factored. There's nothing I can do to x. It's factored already. There's nothing I can do to x plus 4. It's factored already, x plus 4. There's nothing I can do to 4. However, I have to state restrictions. So, restrictions on x. How come I didn't write restrictions here? There were no x in the denominator. No x or x plus 1 or x minus 3. But here I have a problem. Why? I claim that this value in the denominator, or the variable x, cannot be 0. Would you agree? And why would you agree? Or if you disagree, why do you disagree? Exactly. Division. There is no number. Division by 0 is called, and we like to use a fancy word, undefined. It really says in plain English, it doesn't exist. We have no number. If I have $0 and I pick 5 of you to share my 0 with, you will get 0. So 0 divided by a number is 0. But when I say 5 over 0, you will not be able to give me a number. There is no number that replaces 5 over 0. So division by 0 is undefined. Therefore, this fraction will exist if x is not 0. This fraction will exist if x is not what number? -4, of course. How will I determine that? I will write that x plus 4 is not 0. I will move 4 to the other side, and I'll say x cannot be -4. And that's exactly what we have. So what does this mean? It means that when I finish solving this equation, if the solution or solutions I get happen to be 0 or -4, what would you say about the equation? If I don't have anything else, but I have solution 0 or solution -4 or both, what would you say about this equation? The equation has no solutions. No solutions. If I get x equals 15, then that's the solution. But if I get 0 or -4, I'll say, no way, sorry. One of the fractions, or even both maybe, could be undefined. That's not acceptable. Good. I recommend, and remember I said that several times and I will repeat myself, do not change something that works. So if I show you a method that appeals to you, use it. If you have a better method for yourself, use your method, okay? So what I'd like to do here is move 1/4 to the other side. Like I did, I moved 10 to the other side. It changes its sign. I'm going to move 1/4 to the other side. It changes its sign to -1/4. But question is, what is left on this side when I move from one side to the other? 1/4. What is left? Of course. Please remember, all equations have left-hand side, equal symbol, and right-hand side. So we have now 1/x plus 1/x plus 4 minus 1/4 equals 0. Do not write or simplify anything to the sides. I will not look at the problem that is an equation that has the left-hand side, the equal symbol, and 2 other right-hand sides, or 3 other right-hand sides. I will not look at the problem, please. So notice this equation has the left-hand side, equal symbol, right-hand side. This equation has the left-hand side, the equal symbol, and the right-hand side. One of each. Okay. So my next step is to find the LCD. Write a long fraction line, copy the equal symbol, and copy the right-hand side so I don't forget. If I forget to copy the 0 on the right-hand side, I will not be solving. I will be simplifying. And I will not get an x value. Okay, can anyone tell us how many different factors we see here? 3 different factors. 4 is a factor, x is a factor, x plus 4 is a factor. Awesome. This is indeed the least common denominator. All different factors we see. Question for you. Can I write the top as 1 plus 1 minus 1? That would be a terrible mistake. I will never be able to do that. So please follow through with me. X was multiplied by what to get this? By 4 and by this, which means 4x plus 16. Which means the numerator has to be multiplied by the same identical quantity. If I change the denominator of a fraction multiplying it by 4 times x plus 4, I have to do the same thing to the top. I have to multiply the top by 4 times x plus 4. X plus 4 was multiplied by what to get this? I have to multiply, thank you very much. I have to multiply the numerator of that fraction by the same quantity. 4 was multiplied by what to get this? Say it again. Don't be shy.
X squared plus 4x.
X squared plus 4x, indeed. Thank you very much. X squared plus 4x. This is not a trivial situation. It's not a trivial problem at all. As I mentioned, some of my calculus students can. So it's not an easy situation. It has a lot of steps. You have to follow through step by step, etc., etc. Now, can anyone give us the numerator?
4x plus 16
Excellent.
plus 4x
Excellent.
minus 2x, x squared plus 4x.
I cannot just distribute to the first term without distributing to the second term. Is that clear? So we are distributing -1 to x squared and also -1 to 4x. What follows next is, can anyone tell us or guide us through the next step? What do we need to do next? We must combine like terms. Happily, these two go away. In descending order, -x squared plus 4x plus 16. And I just now realized that I didn't give you an example or show you an example of the negative leading coefficient. Thank you. This is going to be our example. Over 4x, x plus 4. Is this clear so far? Yes? Okay. Now I have two options. Option number 1 is to say a fraction is 0 only if or only when what? What has to happen for a fraction to be 0? Say it again.
A or B equals 0?
If b is 0, we're in big trouble.
A equals 0.
Excellent. Only if a is 0. Do we understand why when b is 0, we are in big trouble?
It's not divided.
Undefined. Excellent. So this is one option. So from here you will say what? What is the numerator of this fraction?
So -x squared plus 4x plus 16 equals 0.
We're going to come back to it in a minute. Here's option number 2. In option number 2, we write this. Is this true? Can I write 10 as 10 over 1? Of course. Can I write -7 as -7 over 1? Can I write 0 as 0 over 1? It's a number. Everything over 1 is itself. So now this becomes a proportion. Only in a proportion I'm allowed to do what? Something very special that is not possible in anything else. This is a proportion. So a fraction on the left, the equal symbol in the middle, and a fraction on the right. This is a proportion. If you put plus 1 here, this is no longer a proportion, and what I'm showing you is not allowed. But as long as it's a proportion, what will I write? What happens and what can I do in a proportion that I cannot do in any other type of? Excellent, thank you very much. AD times D, in other words, equals B times C. So that's my second option here. When I multiply this by 1, what do I get? Itself equals. When I multiply this by 0, what do I get?
0.
Exactly the same equation. No matter which method I use, I still get negative x squared plus 4x plus 16 equals 0. Okay, so let's summarize. We are far from being done. So first of all, we had a rational equation. We identified it correctly. Then in number 2, we factor the denominators if they are not already factored. In step number 3, we stated restrictions. In step number 4, we moved everything to one side and we set it equal to 0. In the next step, we found the LCD. The next step, we found the adjustments for the top. The next step, we said, okay, either I use the concept of a proportion, or I say a fraction is 0 only when the top is 0. And I set the top equal to 0. That's where we are right now. Okay, so now this is a what type of equation? We started with a rational. We changed it into a rational but special type proportion. But now I have this equation. Quadratic, awesome. Good. I see a quadratic equation with a negative leading coefficient. I refuse to solve a quadratic equation with a negative leading coefficient, so I will multiply by negative 1. Can anyone dictate? Do you have to multiply by negative 1? No, bless you. But if you don't do it, it's going to be more difficult. So when we multiply both sides by negative 1, can anyone dictate? Excellent.
Plus, no, sorry, minus 4x.
Excellent.
Minus 16.
Excellent. Excellent. So now, since we reviewed factoring, I should determine this in a blink. So let's determine this. The product is excellent. And the sum is excellent. If it's not factorable, then we have to wait to solve it using the quadratic equation. So 16 will be only 1 times 16, 8 times 2.
I thought 16 was supposed to be positive. So multiplying it by oh, I thought, no, yeah, I'm not saying the next step.
Maybe I did.
I'm pretty sure I'm bad with that.
So I'm checking. Can I read this back to you? Maybe from the very beginning. The solution doesn't have to be an integer. I don't know. So let's check and make sure that I copied it correctly. You gave me 1 over x plus 1 over x plus 4.
Mm-hmm.
Is it plus here?
It is, yeah, they're all
And then equals 1/4. Okay, I'm
Alright,
checking.
I'm
I'm checking. I'm sorry.
But I'm bad with signs. I was.
No. Maybe let me double check. So we had negative 1. Oh, I see my mistake. Here it is. Oh no, it was plus. Just 1 over 4 was moved. Okay, sorry. Okay, everything is fine so far. We found 4x plus 4. This was indeed 4x. If you see something, you may be right, so I'll rather go back and check. So x plus 4, yes, that was 4x, and 4, yes, x squared plus 4x, yes. And this was 4x plus 16, correct, and plus 4x, and minus x squared minus 4x, that's correct. So these two went away, the negative 4x plus 4x. Negative x squared and plus 4x and plus 16, that is okay. And then I don't see any error. We multiply both sides, so if it's not factorable. So we only have 1 times 16 or 2 times 8 or 4 times 4. So nothing works. So in that case, are they telling us to write an exact answer? Are they telling us to approximate? Is it from my math lab, my lab math, the problem?
Oh, yeah.
So did they say to approximate, or did they say an exact answer, or that's okay.
So you just said solve the equation by the method of your choice.
Okay, so we can only use the quadratic formula on this one. Okay, so let me refresh your memory. So if we have ax squared plus bx plus c equals 0, only if the quadratic equation is in this format, which it is at this point as you see it, we can write negative b plus or minus the square root of b squared minus 4ac over 2a. Sometimes in fine print they write approximate or use the exact solution or who knows. So that's why I was asking. Is there something in parentheses saying present the solution blah blah blah, or use parentheses or use a comma, or sometimes they say that. And that gives us an indication whether they expect an exact or an approximation. Okay, it doesn't matter. So let's continue. So x equals, can anyone give us negative b? Negative b, it is 4 indeed. Plus or minus the square root of b squared. Indeed, very good, 16. Minus 4 times a, which is 1, times c, which is negative 16, divided by 2a, which is 2. So this will be x equals 4 plus or minus. 4 times 16, it's 64 with plus. So this is the square root of 16 plus 64 divided by 2. And that happens to be 4 plus or minus the square root of, and I think it's 80, divided by 2. So no, we couldn't have not factored, of course. And now when we simplify this, the square root of 80 will be the square root of 16 times 5. Why 16 times 5 and not 20 times 4? Because I need to fully simplify this. So this will be the square root of 16 times the square root of 5. And this happens to be 4. So if they want the exact, this is still not done, because we have to simplify the 2. If you simplify 2 here, it will be a terrible mistake. If you simplify 2 here, it will be a terrible mistake. One option would be to separate the fraction like this. That's one option. And now you can simplify each fraction by itself or factor out. So then x equals 4 over 2 is 2. 4 over 2 is 2. And this is the final exact answer. If they want an approximation, is a different story.